Hello everyone. Regression is probably the commonest multivariate technique used in ascertaining association between dependent and independent factors. This technique is quite intuitive, comparatively simple to implement and interpret the results. Today we will try to understand the genesis of concept regression towards mean and to understand implications of this concept in regression analysis. We will also know different uses of regression analysis. Coming to genesis of concept of regression towards mean. Sir Francis Galton was the first to introduce this concept in his research on heredity. He carried out experiments on sweet peas and also studied human stature. Let us see his experiment on sweet peas. He took seeds of sweet peas and categorized them based on their sizes. So the seeds were categorized as very large, large, average, small and very small seeds. And each of these category of seeds were sown in different plots. And then he got the yield. And yield was also categorized on a similar basis. What he observed was in the plots which were sown the very large seeds, he had considerable number which were smaller than the seeds sown. Similarly, if you see the smallest plots, yield of the plots of the smallest seeds, he noticed considerable number, the sizes of the yield were higher than the seeds sown. His human stature studies, he took parents who were very tall, and similarly he took parents who were very small, and then he studied the height of offsprings. He noticed that the adult offsprings who had tall parents were shorter than their parents. Similarly, adult offsprings or shorter parents were taller than their shorter parents. So he concluded that the generations moved towards population mean. And he described this phenomena as reversion towards the mean, and then the term reversion was replaced with regression, and then we started calling it regression towards mean. Let us understand what is the implied meaning for the term regression towards mean and how this phenomena is used as a statistical tool in health and social sciences with an example. Let us presume that there are 30 participants in this class and I am interested in studying their height. These 30 participants form the population. So by the principle of regression towards mean, all 30 should have equal height equal to the population mean. And if anyone's height differ from the population mean, then there should be a reason for that. We can identify that cause and attribute a specific portion of deviation to a particular cause. This diagram shows how BMI is attributed to the deviation of systolic blood pressure from population mean. You can see, ideally, as per the concept of the towards mean, everyone should have a blood pressure which is equal to this population mean. But many of them deviated from this population mean. What could be the reason? One of the reason is BMI. A part of the deviation in systolic blood pressure is explained by BMI, and this is the part that is explained. This is the part that is explained by BMI, and the rest of the portion is not explained by the BMI, and there could be different factors which can explain this deviation, unexplained deviation, and few factors we may not know as well. So this is how we can use phenomena of regression towards mean to find out cause of deviation and what proportion of deviation can be attributed to a particular cause. Phenomena of regression towards mean give us a base to calculate deviations, and the whole calculations are based on this phenomena of regression towards means, meaning everyone should have a value which is equal to population mean. This regression analysis is used as a step towards establishing causal association. It is based on two causal theories. Rather, it uses two causal theories. Primarily, it is based on counterfactual theory of causation of Lewis, and it also uses sufficient cause component cause theory of Rothman. Understanding these theories will help interpret results appropriately. What is the purpose of regression analysis? This regression analysis is helpful in ascertaining the probable form of the relationship between the variables. Regression model is nothing but a statement of relationship between independent and dependent variable. And by using this regression model, we predict or estimate the value of one variable corresponding to a given value of another variable. This is the general form of regression equation. Y is equal to alpha plus beta x plus e. Y is the typical value of subpopulations of Y. Alpha is the intercept on x-axis and beta is the slope of the line. E is called the error term. It is the amount by which Y deviates from the mean value of subpopulation of Y. Typical questions that we answer through this regression model is, for a given age, say 50 years, what is the systolic blood pressure of the person? The different uses of regression analysis are descriptive. It gives us the strength of association between the outcome and the factors of interest. So rather it describes the strength of association between outcome and factors of interest. We can use it to predict the probability of a new case. If a certain person is there, what is his probability to be a case? That we can find out. We can also find out or predict value of a variable. We can identify important risk factors affecting the outcome, and we can also adjust for confounders. So there are four uses: descriptive, prediction, identification of predictors, and adjusting the confounders.